We'll finish up the sequence of videos, talk about Landsat. Or maybe you just love Landsat. You found your way here. I love Landsat. Landsat is our series of satellites, not just one. There's 9 of them working on Landsat 10 as of the time of this recording, that provide us with the most coherent and long-term record of the planet, of achievements of humanity. Landsat's just one of the coolest, the whole system. Now, Landsat, being a satellite platform, requires a lot of work and funding and politicalness. So it's important to recognize and discuss that, because Landsat doesn't happen without a whole lot of political wrangling, a whole lot of maybe differences in the understanding of the purpose of a satellite observation program, maybe some suspicion about government-based satellite observation programs themselves. But it's a great story. So Landsat, the whole satellite observation series, comes from TIROS. The TIROS satellites were built to test this idea in the burgeoning beginning of the space age, the space race in the 60s. An April Fool's joke, that's the first picture, television picture from space. A satellite orbiting the planet sent down that image. Now, TIROS kind of grew out of a lot of other US military programs that we don't have time to talk about here. Corona is one worth looking up. Satellite photography. Now, this is a television image, quote unquote, which means it was beamed by satellite. The Corona satellites, the Keyhole program, film in space, take pictures, drop film back to Earth, catch with a plane. Yeah, about as successful as you think that is. Actually, probably more successful than you think that might be. Got really good at catching film canisters. So this is something in the US Department of Defense, the National Oceanic and Atmospheric Administration, NOAA, are all launching weather satellites. There's TIROS in more depth. It's got TV cameras and transmitters and a D-spin mechanism. That's pretty cool. So these are our satellite futures, or I guess this is our satellite past, but at the time, very much the future. As US President John F. Kennedy said in something called the Communications Satellite Act, we are so used to satellite communication. Satellite internet is a very hot topic right now. GPS satellites, all these kind of affordances that it's easy to forget that this was only created 60 or so years ago. The benefits which a satellite system should make possible within a few years will stem largely from a vastly increased capacity to exchange information cheaply and reliably with all parts of the world by telephone, telegraph, radio, and television. Might be worth thinking about how many of those do you rely on to exchange information cheaply and reliably. In any case, satellites were seen as enabling, and certainly did, enable communication to continue and advance and move quickly. Live via satellite became a television hallmark. All of a sudden, we could get reporting on important events or sporting events or news broadcasts from around the world. The moon landing, of course, was transmitted via satellite across the whole world from an Australian repeater base. This obviously continued. We've jumped ahead a few presidents here. But it's interesting and important to note, as we've been talking about remote sensing and data and all this in this series, that remote sensing has been said by a US president in a State of the Union address. The diversity of activities in space shows that space technologies have become an integral part of our lives. Check. In communications, in remote sensing for defense and civilian purposes, and in studies of the Earth and the universe. It's 1980 State of the Union address. The rest of 1980 did not go well for Jimmy Carter. Remote sensing for defense and civilian purposes. Now, certainly the US Department of Defense and who knows which other organizations in the US military and intelligence agencies, and let's face it, in every country's who has satellite capabilities, defense and intelligence agencies have satellites, they're observing things, everything's just going on. It says built, but at the same time, we're building Earth observation satellites for scientific data. This is Nimbus. This is Nimbus temperature data of Africa from 1966. I haven't tracked for a while, but I know that there was work a few years ago taking Nimbus data, this 60s era Nimbus data, and actually getting it into a usable form so that we could actually understand more about ice and temperature in Antarctica to inform our climate models. This data is so important for us to understand how climate has changed. And our terrestrial weather stations, well, in many places go back 100+ years, certainly don't go back that far across all of Antarctica. Very useful, very interesting. So we've been doing this. We've been understanding the value of satellite platforms for Earth observing, for climate data, for land data for a while. Now, in the 70s, Landsat showed up. And the Landsat program was the first program that was built towards establishing a type of sensor, a standardized type of sensor, and establishing a pattern of Earth observation. So this kind of changes the paradigm or changes the game in terms of what type of data we're getting, how we're getting it. And no doubt Landsat was part of the inspiration of Jimmy Carter's State of the Union address in 1980, because these Landsat satellites there'd been a few of them by then. I had to stop and look it up. There had been 3 Landsats by 1980. 2 of them were still active. Now, Landsats with their multispectral sensor were allowing us to understand things in better or broader than visual data. The first Landsat discovered an island off the coast of Canada. They called it Landsat Island. Pretty cool. Found some island there. Now, here's the problem though. So we could talk all day about how cool Landsat is, how cool remote sensing is, what great work there is with spectral data. But again, this is a GIS class, and we've already talked about that a little bit. You would think that something as cool as Landsat and as structurally functional as collecting data about the planet, the whole planet, most of it, on a regular basis that can be used for understanding ecological data, mineral data, economic data, land surface change, all the stuff we do with remote sensing data. You'd think someone would say, oh yeah, that's great, let's keep it. Nope. NASA ran Landsat until 1979 when it was transferred to NOAA. NOAA kicked it to EOSat, which was a government restructuring of the US government under Reagan that did satellite stuff, which then stopped existing in 1992. So NASA and the Department of Defense ran it. The Department of Defense was like, we can't use this for military things. Now, you keep it, NASA. And NASA was like, nope. So they gave it back to NOAA. NOAA in 1998 was like, Landsat is a satellite, but it's not really doing anything atmospheric. We would like to not have it. So USGS took it over, the United States Geological Survey, which actually makes sense. Lots of cool land stuff in Landsat. And so the Landsat football has been kicked around. USGS still runs it, but that doesn't mean it's been necessarily stable. We are on Landsat 9 now, but some of them have had issues. Landsat 6 blew up. I'm sorry, it failed to make orbit. It blew up. Landsat 7, its replacement, ended up having a faulty scan line issue fairly early in its life, which means that you can tell you're looking at a Landsat 7 scene or image because it has like a pixelated lines all over it. That's cool. Landsat 8's amazing. Landsat 9, even more amazing. Landsat 10, which is going to go up, is going to blow everybody's minds. Now, the political relationship with Landsat and Earth observing and climate data is still just as fraught as ever. It's still something that gets squeezed and moved around in the general overall function of who's paying for it, who's working with it. This was during the government shutdown in 2011. We all want a government that lives within its means, says President Barack Obama. But there are still things we need to pay for as a country. Things like roads and bridges, weather satellites, food inspection, services to veterans, and medical research. So there's the tiers. There's the tier list. Roads, bridges, weather satellites, food inspection, veteran services, medical research. The top 6 things to mention. Here's what we have to pay for. Congress, get your act together. And that was fine until, a few months later. The new budget strategy will mean terminating unnecessary programs like the C-27 and a new weather satellite. I guess we don't need to pay for those after all. Our satellite data, our information that we have, our GIS data, everything that we use is influenced by political actions, is influenced by political decisions, and is sometimes controlled by them. The USGS, when it took over, Landsat said, great, we'll take it over. You have to pay for the data. Use of Landsat data went way down because all of a sudden researchers or students like you, learners like you, maybe you're not a student, people who like satellite stuff, like me, suddenly had to pay for it. Well, that policy changed eventually, and now Landsat data is free. Go get some while you can. Maybe it'll change again. Scientific American reported some changes in satellite development under President Trump. The budget outline calls for savings in funding the Polar Follow-On Satellite Program, which could degrade monitoring capabilities for events like snowstorms and hurricanes. Here's Landsat 7. A gorgeous image of the Big Island. Satellite data gives us a view of the world that is impossible otherwise, just like GIS gives us a way to understand spatial relationships that is impossible otherwise. But satellite data is viewed through many different lenses and for many different purposes. It's important as we do our work with it, as we understand how the data is constructed, how the data is modeled, how a spectral line works, what a pixel is, that we're really living within the political realities of how we can use that data as much the technical realities.